Okay, friends, in this video, we will discuss radioactive decay. So let's start radioactive decay. This is a part of nuclear chemistry. So, what is radioactive decay? Radioactivity is the act of emitting radiation spontaneously. For example, if any nucleus which is not stable or which is unstable, then it will continuously emit the radiation. So this phenomena is known as radioactivity. This property of that element is known as radioactivity, and emission of radiation is known as radioactive decay. Why does it happen? Because an atomic nucleus is unstable. Because nucleus is unstable, that's why radioactive decay happens or occurs. How atomic nucleus is unstable? When there is there is no minimization of repulsion between proton and neutron present in the nucleus. That time the nucleus become unstable, and when it is unstable, then it releases energy in order to shift to a more stable configuration. So for example, this is nucleus, this is unstable nucleus. When it emits energy in energy, then it turns into stable nucleus. Okay, so a nucleus emits radiation because it wants to be stable. For example, you can see in this diagrams, there is an unstable nucleus. It can release alpha radiation. And what is alpha radiation? It is combination of two proton and two neutron, uh, which can be said that it is two helium 4. Okay, this is known as alpha radiation. So an unstable nucleus can release alpha radiation. It can release high energetic electron. Those are beta radiation, and it can release high energy electromagnetic photons. Those are gamma radiation. Okay. And one important thing, it can be unstable, or we can release alpha, beta, or gamma radiations by bombardment of nucleus or neutron to the nucleus. Okay, so there are three types of radioactive decay. First is alpha radiation, the second one is beta radiation, third one is gamma radiation. So by releasing these, one of them or one of these radiations, nucleus become stable. Okay, so now radioactivity, there are three or four types of radioactive decay. First is alpha, second is beta, third is gamma, not like this. This is not this, and then neutrons. There are four kind of radiations which can be emitted by the nucleus. So nuclear symbol of alpha is 2He4, beta -1 electron 0, gamma 0 gamma 0. It is gamma radiation, or it may be X-rays, neutron 0 and 0. Okay. Nature of radiation. Alpha radiation is helium nucleus. It is like helium nucleus containing two protons and two neutrons. Beta radiations are very high kinetic energy electrons. Beta radiations are high kinetic energy containing or having electrons. Gamma radiation, these are high frequency electromagnetic radiations. And neutrons frequency is very, very high. Now mass, alpha radiation have a mass 4. Beta radiation have a mass 1 by 1850. So it can be negligible. It is -1. Okay, gamma and neutron radiations have mass 0 only. Now, what are the charges on these? On alpha radiation, there is +2 charge. Beta radiation, it has -1 charge. Neutron and gamma radiations has 0 charges. Now, what is the ionization power? Ionization power means what is the capacity, or in what capacity it can ionize, or it can be ionized. So alpha radiation we have very high ionization power but low penetration. What is the penetration? For example, there are one layer, 2 layer, 3 layer, 4 layer, and these are alpha radiation, so it cannot penetrate. It cannot penetrate like this. But if you will take um, neutron, then it will penetrate all the layers. So this is the penetration. Okay, so alpha radiation have very high ionization power but low penetration. Beta radiation has moderate ionizing power and moderate penetration power. It has a smaller mass and charge than alpha particles. So as compared to alpha particle, beta particle has low mass, low charge. Then gamma radiation, it also has a low ionization power but high penetrating power. So interact dominantly with the electron shell of the atom. So it can easily interact with the electron shell of the atom. Neutron, it has also lowest ionization power. So among alpha, beta, and gamma and neutron, the neutron has lowest ionization power. It has very high penetration power, interact primarily. If it interacts very fast, so these are some characteristics of alpha, beta, gamma, and neutron radiation. Now again, we have to understand what is this, the alpha, beta, and gamma. What happens when alpha, beta, and gamma radiations are released? So when alpha radiation or nucleus undergoes alpha decay, then initially it has ZXA. Okay, the nucleus has ZXA. Okay, now what will happen? It will decrease the mass by 4. Why? Because alpha radiation, we know alpha is 2He4, 2 proton or 4 mass number. So that's why 4 mass number will be decreased by 4, and Z proton number or atomic number will be decreased by 2. It happens after alpha decay. Okay, so this is the in diagrammatic form or pictorial form. We can understand this is the unstable nucleus, and this is alpha particle. When it is released, then there is a vacancy of 4 mass number and 2 proton. Now, when a nucleus undergoes beta decay, initially it is ZXE. When we know that beta radiation is represented by -1 electron 0, it means there is an increment in Z number by 1 because it has -1. Okay, and in mass number it has 0, that's why there is no change in mass number, but there is increase in Z by 1. Now gamma decay, when nucleus undergoes gamma decay, then because we know that gamma decay has 0, gamma 0 means there is no change in proton number or atomic number, there is no change in mass number, so it remains unchanged with respect to atomic and mass number. So A unchanged, Z unchanged. Now positron emission, there is a subatomic particle also. So positron has +1, electron 0. So there is a decrement in proton number by 1, and there is no increment or decrement in a mass number. So that's why after positron emission, A is unchanged, Z decreased by 1. Now electron capture, what happens after electron capture? So electron is related to beta particle. It is very similar to beta particle. So that's why its symbol is similar to beta particle, but after electron capturing, the product is not the same as after emission of beta decay. So initially ZXA. So what is happening? There is A is unchanged. In mass number, there is no difference. Okay. But in case of Z, there is decreased by 1. But in case of beta, it is increased by 1. Electron capturing, Z decreased by 1. But in case of beta, it increased by 1. So this is the simple difference between electron capturing and beta decay. So in case of if we compare positron emission and electron capture, so both are the same. while both symbols are different. Okay, positron emission plus one electron zero, but electron capturing minus one electron zero, but the product is the same after these emission. So for example, in case of alpha decay, suppose 92 uranium 238, this is the initial unstable nucleus. When it releases alpha, there is a decrement in mass number by 4 to 34, and there is a decrease in proton number by 2, so it turns into 90. What is the 90, or whose atomic number is 90? That is thorium. So when uranium 92 to 38 undergoes alpha decay or alpha emission, then it gives thorium 19 to 34. When beta decay, the thorium, when undergoes beta decay, then there is a increment in proton number by 1, or it turns into Pa. Okay, and there is no change in mass number. Gamma decay combines more nuclei. Gamma decay of uranium 238 is like this. Okay, so when this nucleus uranium undergoes gamma decay, then it turns into, there is no change. So when it undergoes gamma decay, so it will also release alpha. It will turn into thorium and it will release 2 gamma. Okay, so this is the thing about alpha, beta, and gamma. So again, you can understand with this slide that how alpha particle is released and what happened after alpha particle uh, got released, and what happens after beta emission, what happened after gamma emission. Now, radioactive decay and kinetics. So, radioactive decay and kinetics. So, radioactive decay follows the kinetics of first order reaction. So, you have to remember that radioactive decay, whatever it is, like alpha radiation or beta or gamma or neutron, always follow the kinetics of first order reaction. So rate is equal to K into concentration of A, and we can write ln AT is equal to minus KT plus ln NO. So ln AT is equal to minus of KT plus ln NO. So it follows first order reaction where N is the number of nuclides, and what would be the half-life? We know that in first order reaction the half-life is 0.6935 K, and what is the K? K is the rate constant. Okay, so rate of disintegration is directly proportional to the number of active nucleons present at the time. What is disintegration? Disintegration means alpha is being released, beta is being released, gamma is being released, for example. Okay, so this is decay is also known as disintegration. So it is directly proportional to the number of active nucleons present at the time. How many nucleons, active nucleons means which are unstable. So how many active nucleons are present, that will decide the rate of disintegration. So minus of d and a by dt is equal to lambda and a. Integrating the differential rate law, at the end we will have log n naught by nt and lambda t. This is the disintegration equation. Okay. Equation. This integration equation where n naught, what is the n naught? N naught is number of nuclei of A at time 0 when just reaction starts. And what is the nt? Number of nuclei at the time of t. And what is lambda? It is decay constant. The expression can be rearranged like nt is equal to n naught e exponential minus lambda t. So this is the radioactive decay and kinetics of first order emission, radioactive emission. So radioactive decay always follow first order reaction, that we have to remember. Now nuclear reactions. What is nuclear reaction? So first we have to understand what is the difference between nuclear reactions and chemical reactions. So let's start the discussion about nuclear reaction and chemical reactions. So chemical reactions and nuclear reactions are differ from each other with such points like in chemical reaction, atoms are rearranged by the breaking and forming of the chemical bond. We know that in case of chemical reactions, the atoms, for example, this is the reaction H2 plus N2 gives NH. Okay, so H2 bond is being broken, N2 bond is being broken, and now new bond and an H is being formed. But in case of nuclear reactions, elements are converted from one to another. For example, there is an X element, it can be converted into another element like Y. In chemical reaction, only electrons in atomic or molecular orbitals are involved in the breaking and forming of the bond. So main role in chemical reaction, the electrons play a key role, or roles are played by the electrons only. But in case of nuclear reaction, there is the role of proton, neutron, and electron. Okay, reactions are accompanied by absorption or release of relatively small amount of energy. When chemical reactions occurred, then the small amount of energy is released. Small amount of energy is released. But in the case of nuclear reactions, the huge amount of energy released. Rate of reactions are influenced by temperature, pressure, concentration, and catalyst. In case of chemical reactions, the rate of reactions can be influenced by temperature, pressure, concentration, or catalyst. But in case of nuclear reaction, there is no effect on of temperature, pressure, concentration, or catalyst. So these are some basic differences between nuclear reactions and chemical reactions.